Welcome to Lecture 5 on the cereal industry, Part 2. This is part of the agronomy subject, which is offered as part of the agricultural degree at North Melbourne Institute of TAFE, an education establishment based in Australia. Please visit our website for further details on our subjects, courses and education products we offer. www.nmit.edu.au. My name is Dr. Nikki Cooley. In this series of lectures, we will talk about the cereal industry. In Part 2, we will concentrate on rice. Ausia sativa, or rice, is one of the oldest cultivated crops by mankind. According to archaeological records, it has been estimated that humans have grown and eaten rice for over 5,000 years. Rice originated in China, India and Indonesia. Rice is a primary grain crop and feeds more than 50% of the world's population. It is the largest production of rice occurs in Asia. Australia is able to produce enough rice to feed 20 million people a year. Australia exports to 60 countries. Typically, it exports around 1.2 million tonnes of rice each year. However, this is very dependent on the amount of water. No water, no crop. The Australian rice industry averages approximately 8.6 tonnes per hectare. In 2010 and 2011, 65,000 tonnes of rice were exported with a total export value worth of 61 million. Australian rice growers use up to 5 times less water to produce a kilo of rice than overseas. The uncertainty of Australia's climate, particularly with respect to rainfall, has led for very interesting times in the rice industry. It has had unique challenges which has resulted in outstanding achievements. Over the last 10 years, the Australian rice growers have improved their water use efficiency by a staggering 60%. These improvements in water use efficiency now outperform the world average. The rice industry is the first Australian agricultural industry to initiate a regional biodiversity plan and a greenhouse reduction strategy. Rice is a multi-tilled grass that averages about 0.19 to 1.8 metres tall. The panicle inflorescence and the lamina and the palea adhere to the grain when mature. Rice is the only grain adapted to moisture-induced anaerobic conditions. It is typically grown in flooded paddocks or in floodwaters. The stem and the root contain large air spaces that allow for air diffusion throughout the plant. The rice leaves, due to these air spaces, are able to float on the surface. Rice is a warm season, short day plant. There are 2 major subspecies: indica, which is adapted to tropical climates and produces a long grain about 8 millimeters in length that is sticky when cooked. And the second is japonica. This is adapted to cooler temperatures, has a shorter grain, approximately 6 millimeters, and is sticky when cooked. Rice is grown predominantly for the consumption of humans. Grain can be ground into flour, or grain can be fermented to produce an alcoholic drink. Rice must be milled before consumption because the flour parts, the lamina and the palea, adhere to the ripe grain. Removal of these results in brown rice. If the rice is then polished, the more common white rice is produced. Rice is composed of 14% protein, 74% carbohydrate. It is high on linolenic omega-6 and lineolenic acids omega-3. The average production of rice in Australia is 10 tonnes per hectare. Water use is averaged at 12 megalitres per hectare. The world average ranges from 15 to 20 megalitres per hectare, and some countries using an upward of 50 megalitres per hectare. The farm gate to Australia is worth 350 million. The total value, which includes export and added value, is worth 800 million. It brings in $4 billion annually. Unlike the other crops we have examined to date, rice is not grown extensively over Australia. It is only grown in a small area, in the Murrumbidgee and the Murray valleys of New South Wales, and a small quantity is grown in Victoria. The rice fields are flood irrigated throughout the growing season, which tends to be October to March. There are 2,000 farms in Australia. The industry is regulated heavily. For example, rice can only be grown in approved heavy clay soils to minimise seepage into the water table. For unrestricted grower, there needs to be 3 metres of continuous clay. Any farm that breaches these water restrictions may be banned from growing rice in the offending paddocks. Australians have developed a unique rice farming system in order to manage the limited water supply that they have. Most countries will grow nothing but rice in a paddock. Australian farmers will plant a second crop, such as wheat, once the rice is harvested. This second crop allows use of the remaining water. It also is beneficial as it allows increased soil nutrients to be taken up, and it gives higher yields and healthier crops. Most farmers also have a 4 to 5 year rotation between paddocks growing rice, thus maintaining soil integrity. The Australian climate and the heavy soils that we have are uniquely suited to the growing medium grain rice, a niche variety produced by only a handful of countries. Medium grain rice is not suited to tropical climates, but the Riverina's dry, hot summer provides ideal growing conditions. All of the rice produced in Australia is from one variety, Japonica, which is being perfectly suited for the dry, temperate microclimate of the Australian rice growing region. Japonica rice is usually grown in temperate climates like California, Egypt, China and Japan. From this variety, different varieties have been bred in order to produce different qualities. For example, Amiro is a semi-dwarf medium grain high yielding rice, while Quest is a new semi-dwarf medium grain short season rice. On the table on the slide are a list of the most common varieties grown in Australia. The largest overseas markets for Australian rice are the Middle East, Papua New Guinea, Japan and other Asian and specific countries. Australian rice breeders have been very successful in the development of rice varieties to meet the demands of different international markets. One such example is for the Opus variety for the Japanese style of cuisine, and the Rizoka, which is fast becoming a premium product in the Middle East. Let us discuss in some detail the management of rice. Let's begin with sowing. Principally, there are 2 methods for sowing rice. These are known as drill sow and aerial sowing. Please refer to the following article on Moodle, Management of Drill Sown Rice, a DPI New South Wales Prime Facts news sheet. This was written by J. Smith, Brian Dunn and R. Ford. Please read this article, and to complete your notes on this topic, describe the 2 techniques. Produce a table that summarises the advantages and disadvantages of each sowing technique. Note what site preparation is required and when is the perfect time to sow. What depth should you sow your rice to, and what is the ideal row spacing. List the herbicide management required. At the beginning of this lecture, we noted no water, no crop. Water management is absolutely essential in the management of rice. The following article, Have I Enough Water to Finish My Rice Crop?, was produced by DPI New South Wales Prime Facts news sheet by Rachel Wentworth. This is uploaded on Moodle. Please read this article and add the points of interest to complete your lecture notes on this topic. ensure you list the key 4 areas of information that you need to determine your water requirements. That is, how much water do you need and have you got enough to get through to the end of the growing season? The second area of management that is important in rice is being able to determine the growth stage, in particular the panicle initiation in rice. Please read the following article identifying panicle initiation in rice by DPI New South Wales Prime Facts, news sheet by Rachel Wentworth, Brian Dunn and Tina Dunn. Also watch the following YouTube video, which shows this identification in action. Please ensure that you answer the following questions. What is the panicle? Why is it important to know the phenological stage of rice? And once you do know that this stage has been achieved, what test as a grower should you conduct before continuing your management? Please ensure that you make these notes and then add them to the lecture notes to complete the knowledge on this topic. DPI have produced an article called 2012 Rice Check Recommendations. This is a very comprehensive overview of rice management. Please ensure you read the article. I am interested in section 6 on the topic of crop nutrition particularly. Please make detailed notes on this topic. What would you sample to determine rice nitrogen? What are rice nitrogen requirements? What other nutrient requirements does rice have? It is important that you make detailed notes here, as this information will be required for one of the later practicals that you will be conducting in this semester. In one of the last articles I'm going to get you to read in this area, it's on the management of rice with respect to quality. Like all industries, as farmers, it's imperative that you understand what are the quality aspects of the food that you are growing. Often you are paid on quality, and in the rice industry that is no exception. Please ensure you read the following Prime Fact Sheet produced by New South Wales Government, Rachel Ward. This is on rice cereal quality, and you can find this article on Moodle. Please ensure that you are familiar with the quality requirements of rice, the different categories that these fall into, and how you can manage your rice better to achieve these qualities. After listening to this lecture, you should be knowledgeable on the Australian rice industry. Even though it is a small industry on a land mass basis, it is nonetheless a significant industry. There are specific challenges which relate to growing rice in Australia, most of them around Australia's climate and how farmers have adapted and in fact produced excellent growing techniques from overcoming these challenges. You should have detailed knowledge of rice development, sowing, nutrient requirements of rice, some knowledge of crop protection of rice, and most importantly, what are the quality components for the rice industry. This brings us to the end of this lecture.